School of Management Studies IGNOU presents an audiobook on the course MMPC-005 Quantitative Analysis for Managerial Applications for MBA program. Block 1 Data Collection and Analysis. Unit 2 Presentation of Data.
Presentation of data. After completing this unit, you should be able to understand the need and significance of presentation of data, know the necessity of classifying data and various types of classifications, construct a frequency distribution of discrete and continuous data, and present a frequency distribution in the form of bar diagram, histogram, frequency polygon, and ogives. Introduction. In the previous unit, we discussed the various ways of collecting data. The successful use of the data collected depends to a great extent upon the manner in which it is arranged, displayed, and summarized. In this unit, we shall be mainly interested in the presentation of data. Presentation of data can be displayed either in tabular form or through charts. In the tabular form, it is necessary to classify the data before the data is tabulated. Therefore, this unit is divided into two sections. Number 1, classification of data, and number 2, charting of data. Classification of data. After the data has been systematically collected and edited, the first step in presentation of data is classification. Classification is the process of arranging the data according to the points of similarities and dissimilarities. It is like the process of sorting the mail in a post office where the mail for different destinations is placed in different compartments after it has been carefully sorted, cut from the huge heap. Objectives of classification. The principal objectives of classifying data are: number 1, to condense the mass of data in such a way that salient features can be readily noticed. Number 2, to facilitate comparisons between attributes of variables. Number 3, to prepare data which can be presented in tabular form. And number 4, to highlight the significant features of the data at a glance. Types of classification. Some common types of classification are: number 1, geographical, that is, according to area or region. Number 2, chronological, that is, according to occurrence of an event with respect to time. Number 3, qualitative, that is, according to attributes. And number 4, quantitative, that is, according to magnitudes. Geographical classification. In this type of classification, data is classified according to area or region. For example, when we consider production of wheat state-wise, this would be called geographical classification. The listing of individual entries are generally done in an alphabetical order or according to size to emphasize the importance of a particular area or region. Chronological classification. When the data is classified according to the time of its occurrence, it is known as chronological classification. Qualitative classification. When the data is classified according to some attributes, that is, distinct categories which are not capable of measurement, is known as qualitative classification. In a simple or dichotomous classification, an attribute is divided into two classes. one possessing the attribute and the other not possessing it. For example, we may classify population on the basis of employment, that is, the employed and the unemployed. Similarly, we can have manifold classification when an attribute is divided so as to form several classes. For example, the attribute education can have different classes such as primary, middle, higher, secondary, university, etc. Quantitative classification. When the data is classified according to some characteristics that can be measured, it is called quantitative classification. For example, the employees of a company may be classified according to their monthly salaries. Since quantitative data is characterized by different numerical values, the data represents the values of a variable. Quantitative data may be further classified into one or two types, that is, discrete or continuous. The term discrete data refers to quantitative data that is limited to integer numerical values of a variable. For example, the number of employees in an organization or the number of machines in a factory are examples of discrete data. Continuous data can take integer as well as fraction values of the variable. For example, the data relating to weight, distance, and volume are examples of continuous data. The quantitative classification becomes the basis for frequency distribution. When the data is arranged into groups or categories according to conveniently established divisions of the range of the observations, such an arrangement in tabular form is called a frequency distribution. In a frequency distribution, raw data is represented by distinct groups which are known as classes. The number of observations that fall into each of the classes is known as frequency. Thus, a frequency distribution has two parts. On its left, there are classes, and on its right, there are frequencies. When data is described by a continuous variable, it is called continuous data. And when it is described by a discrete variable, it is called discrete data. Construction of a discrete frequency distribution. The process of preparing a frequency distribution is very simple. In the case of discrete data, place all possible values of the variable in ascending order in column and then prepare another column of tally marks to count the number of times a particular value of the variable is repeated. To facilitate counting, block of 5 tally marks are prepared and some space is left in between the blocks. The frequency column refers to the number of tally marks a particular class will contain. Construction of a continuous frequency distribution. In constructing the frequency distribution for continuous data, it is necessary to clarify some of the important terms that are frequently used. Class limits. Class limits denote the lowest and highest value that can be included in the class. The two boundaries, that is, lowest and highest of a class, are known as the lower limit and the upper limit of the class. For example, in the class 60 to 69, 60 is the lower limit and 69 is the upper limit. Or we can say that there can be no value of that class which is less than 60 and more than 69. Class intervals. The class interval represents the width or span or size of a class. The width may be determined by subtracting the lower limit of one class from the lower limit of the following class. That is, alternatively successive upper limits may be used. For example, if the two classes are 10 to 20 and 20 to 30, the width of the class interval would be the difference between the two successive lower limits. That is, 20 minus 10 equals to 10, or the difference between the upper limit and lower limit of the same class, that is, 20 minus 10 equals to 10. Class frequency. The number of observations falling within a particular class is called its class frequency or simply frequency. Total frequency or sum of all the frequencies indicate the total number of observations considered in a given frequency distribution. Class midpoint. Midpoint of a class is defined as the sum of class limits divided by 2. Therefore, it is the value lying halfway between the lower and upper class limits. In the example taken so far, the midpoint would be 10 plus 20 divided by 2, which is equal to 15, and that is corresponding to the class 10 to 20 and 25 corresponding to the class 20 to 30. Type of class interval. There are different ways in which limits of class intervals can be shown, such as number 1, exclusive and inclusive method, and number 2, open-end. Exclusive method. The class intervals are so arranged that the upper limit of one class is the lower limit of the next class. In the exclusive method, it is always presumed that upper limit is excluded. Inclusive method. In this method, the upper limit of one class is included in that class itself. In the inclusive method, it is presumed that upper limit is included. It may be observed that both the methods give the same class frequencies, although the class intervals look different. Whenever inclusive method is used for equal class intervals, the width of class intervals can be obtained by taking the difference between the two lower limits or upper limits. Open-end. In an open-end distribution, the lower limit of the very first class and upper limit of the last class is not given. In distribution where there is a big gap between minimum and maximum values, the open-end distribution can be used, such as in income distributions. The income disparities of residents of a region may vary between Rs 800 to Rs 50,000 per month. In such a case, we can form classes like less than Rs 1,000, 1,000 to 2,000, 2,000 to 5,000, 5,000 to 10,000, 10,000 to 25,000, 25,000 and above. Remark. To ensure continuity and to get correct class intervals, we shall adopt exclusive method. However, if inclusive method is suggested, then it is necessary to make an adjustment to determine the class interval. This can be done by taking the average value of the difference between the lower limit of the succeeding class and the upper limit of the class. In terms of formula, it will be shown as correction factor equals to lower limit of second class minus upper limit of the first class divided by 2. Guidelines for choosing the classes. There are certain guidelines which are useful in choosing the class intervals. They are: number 1. The number of classes should not be too small or too large. Preferably, the number of classes should be between 5 and 15. However, there is no hard and fast rule about it. If the number of observations is smaller, the number of classes formed should be towards the lower side of this limit, and when the number of observations increase, the number of classes formed should be towards the upper side of the limit. Number 2. If possible, the widths of the intervals should be numerically simple, like 5, 10, 25, etc. Values like 3, 7, 19, etc. should be avoided. Number 3. It is desirable to have classes of equal width. However, in case of distributions having wide gap between the minimum and maximum values, classes with unequal class interval can be formed like income distribution. Number 4. The starting point of a class should begin with 0, 5, 10 or multiples thereof. For example, if the minimum value is 3 and we are taking a class interval of 10, the first class should be 0 to 10 and not 3 to 13. And number 5. The class interval should be determined after taking into consideration the minimum and maximum values and the number of classes to be formed. For example, if the income of 20 employees in a company varies between rupees 1100 and rupees 5900 and we want to form 5 classes, the class interval should be 1000. Hence, the equation would be 5900 minus 1100 divided by 1000, which is equal to 4.8 or 5. Cumulative and relative frequencies. It is often useful to express class frequencies in different ways. Rather than listing the actual frequency opposite each class, it may be appropriate to list either cumulative frequencies or relative frequencies or both. Cumulative frequencies. As its name indicates, it cumulates the frequencies starting at either the lowest or highest value. The cumulative frequency of a given class interval thus represents the total of all the previous class frequencies, including the class against which it is written. Relative frequencies. Very often, the frequencies in a frequency distribution are converted to relative frequencies to show the percentage for each class. If the frequency of each class is divided by the total number of observations, that is total frequency, then this proportion is referred to as relative frequency. To get the percentage for each class, multiply the relative frequency by 100. There are two important advantages in looking at relative frequencies or percentages instead of absolute frequencies in a frequency distribution. They are: number 1, relative frequencies facilitate the comparisons of two or more than two sets of data. And number 2, relative frequencies constitute the basis of understanding the concept of probability. Charting of data. Charts of frequency distributions, which cover both diagrams and graphs, are useful because they enable a quick interpretation of the data. A frequency distribution can be presented by a variety of methods. In this section, 4 popular methods of charting frequency distribution are discussed in detail. They are: number 1, bar diagram; number 2, histogram; number 3, frequency polygon; and number 4, ogive or cumulative frequency curve. Bar diagram. Bar diagrams are most popular. One can see numerous such diagrams in newspapers, journals, exhibitions, and even on television to depict different characteristics of data. For example, population, per capita income, sales and profits of a company can be shown easily through bar diagrams. It may be noted that a bar is a thick line whose width is shown to attract the viewer. A bar diagram may be either vertical or horizontal. In order to draw a bar diagram, we take the characteristic or attribute under consideration on the x-axis and the corresponding value on the y-axis. It is desirable to mention the value depicted by the bar on the top of the bar. Take the years on the x-axis and the population figure on the y-axis and draw a bar to show the population figure for the particular year. As can be seen from the diagram, the gap between one bar and the other bar is kept equal. Also, the width of different bars is same. The only difference is in the length of the bars, and that is why this type of diagram is also known as one-dimensional. Histogram. One of the most commonly used and easily understood methods for graphic presentation of frequency distribution is histogram. A histogram is a series of rectangles having areas that are in the same proportion as the frequencies of a frequency distribution. To construct a histogram on the horizontal axis or x-axis, we take the class limits of the variable, and on the vertical axis or y-axis, we take the frequencies of the class intervals shown on the horizontal axis. If the class intervals are of equal width, then the vertical bars in the histogram are also of equal width. On the other hand, if the class intervals are unequal, then the frequencies have to be adjusted according to the width of the class interval. It should be noted that the area of the histogram represents the total frequency as distributed throughout the different classes. When the width of the class intervals are not equal, then the frequencies must be adjusted before constructing the histogram. It may be noted that a histogram and a bar diagram look very much alike but have distinct features. For example, in a histogram, the rectangles are adjoining and can be of different width, whereas in bar diagram it is not possible. Frequency polygon. The frequency polygon is a graphical presentation of frequency distribution. A polygon is a many-sided closed figure. A frequency polygon is constructed by taking the midpoints of the upper horizontal side of each rectangle on the histogram and connecting these midpoints by straight lines. In order to close the polygon, an additional class is assumed at each end having a zero frequency. If we draw a smooth curve over these points in such a way that the area included under the curve is approximately the same as that of the polygon, then such a curve is known as frequency curve. Remark: the histogram is usually associated with discrete data and a frequency polygon is appropriate for continuous data. But this distinction is not always followed in practice and many factors may influence the choice of graph. The frequency polygon and frequency curve have a special advantage over the histogram, particularly when we want to compare two or more frequency distributions. Ogives or cumulative frequency curve. An ogive is the graphical presentation of a cumulative frequency distribution, and therefore, when the graph of such a distribution is drawn, it is called cumulative frequency curve or ogive. There are two methods of constructing ogive. Number 1, less than ogive, and number 2, more than ogive. Less than ogive. In this method, the upper limit of the various classes are taken on the x-axis and the frequencies obtained by the process of cumulating the preceding frequencies on the y-axis. By joining these points, we get less than ogive. More than ogive. Similarly, more than ogive or cumulative frequency curve can be drawn by taking the lower limits on x-axis and cumulative frequencies on the y-axis. By joining these points, we get more than ogive. The shape of less than ogive curve would be a rising one, whereas the shape of more than ogive curve would be a falling one. The concept of ogive is useful in answering questions such as how many companies are having sales less than rupees 52,000 per day or more than rupees 24,000 per day or between rupees 24,000 and rupees 52,000. Now let's summarize the unit. Presentation of data is provided through tables and charts. A frequency distribution is the principal tabular summary of either discrete or continuous data. The frequency distribution may show actual, relative, or cumulative frequencies. Actual and relative frequencies may be charted as either histogram or a bar chart or a frequency polygon. Two graphs of cumulative frequencies are less than ogive or more than ogive.
We were listening to the audiobook by the School of Management Studies IGNOU for MBA program, course code MMPC-005, Quantitative Analysis for Managerial Applications. Course Coordinator, Professor Anurag Saxena, School of Management Studies IGNOU. Voiceover by Harpreet Kaur. Edited by Uday Sharma. Program assisted by Tarannum Jahan and Jagbandhu Jana. Program produced by Dr. Manoj Kumar Singh. This program was brought to you by Electronic Media Production Center of Indira Gandhi National Open University.